The electron is to chemistry what money is to capitalism. It's all about who has it, who wants it, and what they're willing to do to get it. Electrons are what make it possible for atoms to bond with other atoms to form molecules, and when that happens, a tremendous amount of energy can be exchanged in the process. But not all chemical reactions involve electrons being exchanged. Acid-base reactions, for example, are more about swapping protons. But because electrons are the real core of the realm in chemistry, the most important reactions that take place on Earth involve the transfer of one or more electrons from one atom to another. These are redox reactions. Redox, which is a portmanteau of reduction oxidation.
But what's up with those words? You know what reduction is, making less of something, and then oxidation maybe has something to do with oxygen, well, sometimes, but not always. These are actually super terrible choices for what is actually happening in redox reactions, but we are stuck with them. Reduction is when a substance gains electrons. Yes, it gains, which is the opposite of what the word produce means. Fantastic. And yes, sometimes I want to punish the people who named these things so inaccurately, but they didn't know any better and they're all dead, so we can't do anything about it. Proto-chemists would make pure metals by heating or smelting their ores. And they noticed, during the smelting, that these substances would become lighter, so I guess it's not crazy that they decided to say that these substances were being reduced. Our old French friend Antoine Lavoisier figured out that this was because oxygen gas was actually leaving the compound, making it lighter. What he didn't know was the actual chemistry involved. Oxygen is, unsurprisingly, the quintessential oxidizer. It pulls electrons off of one molecule to make itself more stable, but if you heat it up enough, it gets all energetic. Today, we understand that oxidation and reduction are all about electron transfer. So you might think that we'd rename them, and some chemists have tried, producing terms like electronation and de-electronation. But once a set of terms is decided upon and used for a while, it's pretty difficult to uncreate it. So we're stuck. To keep these seemingly nonsensical names straight, I rely on the phrase oil rig. Oxidation is loss of electrons, reduction is gain of electrons. We just gotta know this stuff, because it's everywhere.
When your cells convert sugar into energy so you can move and breathe and think, that's redox. When plants photosynthesize sunlight into food, that's redox. The battery powering your laptop, redox. Fire, also redox. But the example we're going to be examining today is a redox reaction inside of a breathalyzer. But before we get into the science of it, what exactly is a breathalyzer? A breathalyzer is a device for estimating blood alcohol content, BAC, from a breath sample. The invention of the breathalyzer provided law enforcement with a non-invasive test providing immediate results to determine an individual's BAC at the time of testing. It does not, however, determine an individual's level of intoxication, as this varies by a subject's individual alcohol tolerance. The BAC test result itself can vary between individuals consuming identical amounts of alcohol due to gender, weight, and genetic predisposition. Breath analyzers do not directly measure blood alcohol content or concentration, which requires the analysis of a blood sample. Instead, they estimate BAC indirectly by measuring the amount of alcohol in one's breath. Inside of a breathalyzer, there is a solution of dichromate ion. When you breathe into a breathalyzer and you've been drinking, ethanol from the alcohol will react with the dichromate inside the breathalyzer. This is the equation to represent this reaction.
Oh, something good. Oh, something good. Oh, something good tonight.
Now that you understand how a breathalyzer works and have the equation, all that's left is to solve the problem, like I've done here. I created two half reactions with the equation given, and then balanced them both using waters, hydrogens, and electrons.